CGST successfully demonstrated a space-to-ground optical communications link on its Jilin-1 satellite, boasting rates in excess of 10 gigabits per second. The satellite is part of a broader constellation of 40-plus commercial imaging satellites scheduled to complete in 2025. The advent of optical space communications is a paradigm shift in the world of space. For governments, the narrow beam provides natural security along the space link, whereas radio frequency beam spreading may provide unintended access for adversaries. Shantanu Gupta of Aerospace Corporation states, "You may send the RF beam to the satellite you intend to, but behind it, in the shadow, there is another." When considering the attack vectors for satellites and constellations, optical communications may force would-be attackers elsewhere in the system looking for vulnerabilities in the user segment or ground segment. This imposes a greater challenge on system administrators to ensure the sites and connections between the ground segment operations and ground entry points are secure and resilient to threats such as hacking, denial of service, or malware. The Space Development Agency is committed to optical space-to-space and space-to-ground links as part of its transport layer network. This has sparked a race among startups and established companies to build optical space terminals to provide resilient and redundant global access to data collected from space. The next challenge will be properly storing and securing the data on the ground. The shift to optical communications will also spark a change to the architecture of future space systems. A larger bandwidth on the ground provides opportunities to collect and transmit larger volumes of data, enabling new use cases such as decentralized space-based SDA or increased frequency of remote sensing operations.